Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, Episode 27, Artificial Intelligence Theory. Take it away, Jason.
Hey, so we're back from vacation. Pretty excited about that.
Yeah, we took a break. Sorry, that was my fault.
No, it wasn't your fault.
Well, it wasn't really my fault.
It was the end of the season.
Oh, is it? Oh, yes. Okay.
And now it's the beginning of another.
We're starting a new season.
Yes. We're pretty excited though to be back.
It works for TV shows, so why doesn't it work for us?
Yeah, I mean they have to go celebrate on their private island that they bought in the Bahamas with all their millions as actors, and
Just like we did.
Yeah, that's exactly what we did.
The show earned us our first $1 million, and so we took a couple weeks off.
Yeah, right.
Wait, that's not what happened to you?
Wait, you made...
I owe you your share. I'm sorry. Sorry. I spent it all already.
No, on margaritas.
Well, I'll just have to do another 26 episodes.
Yep. So, yeah, pretty exciting to do our 27th episode. And I have the first news article. It's pretty interesting. I posted this on G+, so some of you who are following the Programming Throwdown community got sort of a sneak peek on this article. But yeah, I thought it was pretty funny. Basically, a indie game company made a Game Dev Tycoon, which is sort of like one of these there's these like SimCity kind of games where you have some complex adaptive system. So some sort of a system that's running around, and your job is to sort of tease apart these variables that you don't really know. Like for example, in SimCity, there's like crime is created from residential zones, and you put police stations to reduce the crime. But that takes money and space, and so you have to make these trade-offs, things like that. And you start to...
I think you just sucked all the fun out of SimCity.
Yeah. You start to like learn the dynamic. Half of the fun is like learning the dynamics of the sim and all that. So these guys made a game dev sim where you're like a few guys in a base.
So you make choices about what you want to spend your money on about making a game.
Hacking on games, and you can like choose, do I want to buy like the PS3 dev kit, which costs $100,000 but has a lot of...
But neither of us have played this game, so this is speculation.
Oh, no, I have.
Oh, you did? You played it? Oh, okay. Yeah. Never mind. Jason has played this game.
Yeah. Or just make a PC game on the web. So it's pretty fun. It's kind of a cute theme, cute story. So they did something pretty fun where they released a quote-unquote cracked version of their own game as soon as they released the game and put it on Pirate Bay. What they did was, if you pirated the game using their cracked version, about halfway through the game, people start pirating your in-game games that you're producing.
You must go deeper.
And you run out of money, and you fail the game. And I thought it was pretty fun.
So the pirates keep stealing enough that you can never win.
Yeah, exactly.
So you start to just do worse and worse and worse.
Yeah.
So it's like effectively a not demo.
Yeah. It's basically, it's the illusion that you're getting the full game, but you're really getting, the first 30 days of game time or whatever.
But I think that's fair. Like,
yeah.
I mean, this is what people always say, right? Like, oh, I downloaded this game so I can see if I like it or not. If I like it, I'll buy it.
Yeah.
But if you play it halfway through before this happens, or essentially you really liked it, you should have probably bought it by then.
Yeah, I mean, I was super pissed when I'm just kidding.
Oh, no. The truth comes out, right?
But it's a pretty funny article. Some people posted on their forums saying, hey, pirators keep, stealing my game. Can I research DRM in the game and stuff like that? So.
Oh, wait, that'd be really funny, actually. Yeah. I want to learn how to DRM the game that I cracked.
Yeah.
I want to learn to DRM in the game, which oh, God, this is confusing.
Totally Inception moment there.
Yeah, this has happened before. A couple of people have done this, like where I think one person like released a version of the game, but in the game you wear a pirate hat if you download the version, like just like to be cutesy, like remind you or whatever.
Actually,
but legally, like I guess it's weird, right? Because if you can't get in trouble for downloading a cracked version that the publisher put out. So like I think not that these people, I think these people have no intention of suing the people stealing, but I don't think you ever like.
Right.
You couldn't sue somebody for downloading a version you released.
Yeah, I mean, and also there's an element of entrapment too. Like if there's a game and it's new and it's hot and you put it out on Pirate Bay immediately, maybe some people couldn't even buy it yet. I mean, I don't know exactly when they put it out and when they made the game available in different countries and whatnot. But you might get someone to pirate the game who wouldn't have if you hadn't done that, right? So, yeah, I don't think you can go after them. But actually, there was one game, and I think it was Squaresoft. They made a game for Android. This is pretty cruel. Oh, no, it was Earthbound. Remember the game Earthbound for Nintendo?
Vaguely.
So, if you copied that game, like if you tried to dump the ROM, they had something in the game, I don't remember specifics, but you'd get to the boss after playing for 30 or 40 hours, and the game would crash. Like, purposely crash right there. That's pretty devastating.
Well, on a similar thing, talking about pirates, the much hyped new Daft Punk album, Random Access Memories.
Pretty awesome.
I don't even think, as of this recording, I don't think they have actually even fully released it yet. But what they did was on iTunes, you can actually go on your computer and stream the whole album. So there's a couple interesting caveats. One is that like it streams all at once. So I went and listened to it, but like there's no track, so you have to listen. Like you can pause it and come back. And you can move around in the song, I think, but you can't actually like do like next track, or shuffle or any of that, right? You just listen front to back. The quality seemed okay. I wasn't really like listening to it in an environment where I could tell if it was a really high quality stream or not, but it seemed okay. People were saying like that. I guess a version I didn't quite follow, but a pirated but lower quality version had been like put onto the torrent sites right before this. It's like people were confused, like did they steal it from this streaming site or something? And it turns out now, like this happened a couple days ago that they released the streaming version, that somebody did find a way to basically anytime iTunes does this, you can go download it from the stream. Basically, they're just streaming a file, so you can find a link to that file, basically, and then just download it. Or, of course, you could always just record it.
Just capture the audio.
But it's interesting because if you're going to do that hassle, like presumably you would probably download it somewhere else anyways. Like, but it's interesting to try to maybe get more people to buy it. They'll do this. I mean, from my impression, Daft Punk has more money than they care to what to do with. So like I don't know that they super care like if people steal their album or not, which may be different for small people. But this is kind of an interesting move to head off, people trying to release it earlier, get the scoop.
Yeah, there was a TED Talk about a lady who, going back to your point about big versus like small artists. She, from day one, made all of her albums free and did everything off donations and merch sales at her concert. And she did remarkably well. So, like, the studies show that if you release all the music for free, more people will come to your concert, and enough of those people will buy T-shirts and bracelets or whatever. Especially, she kind of, like, she'd make it a point in her concert to be like, hey, if you like it, pay money for something,
Yeah, please support us.
A little bit of psychology there. You have to do kind of the right thing there. But yeah, it worked really well for her.
Yeah, I think music industry is probably going to break into pieces where like different people earn living in different ways or whatever. Right. But I have heard this story over and over again that like if you kind of just give it away for free and then charge for your concert and for merchandise, like you can do pretty well. But it's increasingly difficult to charge for the music itself.
Right.
And people are saying like with increasing like this, RDO and Spotify, and then recently Google announced they're going to be doing something similar. Yep. It's rumored Apple's going to do something similar as well, these like radio things, but they pay ridiculously low. Like it's like 100 streams of your song and you'll get 3 pennies or something.
Yeah, exactly.
It's like some ridiculously bad deal. So like charging for that is really, really hard.
Yep. I mean, and it makes sense that, the concert, even when people were paying say like $1 a song on iTunes, right? That's still nothing compared to $70 a ticket to go to a concert. And if you go to a concert, you're probably going to have to bring a friend, right? Unless you want to go alone. So that's like $140 they're making. You have to sell
but it's not scalable, right? I mean, ideally, you would like to be able to sell your album digitally all over the world with basically no cost. Versus if you do a concert, you have to pay to rent the venue. You have to go there. You can only do it for so.
That's a good point.
I saw and I forgot the name of it now, but there's some artists are doing like concerts online where like you can pay like $5 or whatever and like watch them play a couple of songs on like YouTube, like as opposed to recording a video or streaming it live though, you like people buy to like have you play or whatever. And I thought that was kind of interesting, like, okay. That's another way to do it, like a more quote-unquote intimate setting, I guess, like with only the really diehard fans.
It's like what Udacity is to colleges. They're trying to do to concerts.
Yes, maybe. Okay, I don't know. That point escapes me.
Yeah. Okay. But yeah, another article is pretty interesting. North Carolina has banned. So technically, they haven't banned Teslas, but they've effectively
Tesla
banned,
sales.
Right, but they've effectively banned Tesla sales. Basically, so apparently, to have a car dealership, you have to like meet a bunch of criteria, and one of the criteria is you have to be in the state and employed in the state, things like that. So. So, there's a lot of, for example, if you go to your neighborhood, Ford or Cadillac or whatever dealership, they have, a general manager for that dealership who lives in that state, et cetera. And they have a set of, certified car salesmen, et cetera. So Tesla didn't want to do any of that. They wanted to sort of take a page from Apple's textbook and just have a bunch of stores with, a couple of cars and then some, Tesla geniuses like the Apple geniuses, but they would really kind of route you through either a phone or an online system or something like that, and you custom order your car, etc. So they were going that route, and anytime you go against, the status quo, you're going to run up against people with a lot of money and therefore a lot of resistance. And so apparently there was some lobbyists who gave the senator of North Carolina a bunch of money, and he passed a law, pushed through a law saying that no, if you don't have a certified dealership, you can't sell cars in our state.
Yeah, it's a really subtle issue where there are established car dealerships, and I guess the way these things are currently written, like I think you're alluding to, it's like the people who make cars aren't allowed to sell directly to a consumer.
Right.
For whatever. Probably, I'm sure I'm going to trust that was a legitimate reason at one point about why you would want to buy from someone else as opposed to directly from the people who made the car. That this whole infrastructure was created. And like I said, I'm sure there are legitimate reasons. I just don't know what they are.
I don't know.
But Tesla now, is trying to skip that. Like, we don't want middlemen. We just want to sell directly and help lower costs. In addition to all the other things they're doing with making the electric car and all that. This is one of the ways they're trying to be different. And so, like you said, it's just a showroom, but not actually a dealership kind of thing. And then people just kind of buy from Tesla directly in California.
Right.
And then, they just bring the car to them or whatever. Yeah, it's like Amazon. Like, you just buy your car on Amazon and then just deliver it to your door.
Yeah, and it just shows up.
But then you want somewhere to go sit in the car and try it or whatever, presumably.
Right.
But like you said, this makes a lot of established people very upset. It's kind of nerve-wracking, though, that, they're not just trying to hurt Tesla, but they're also concerned, maybe or maybe not, they're concerned about Tesla. But I think there's also some other thing where maybe they're concerned about Ford saying, wow, this works really well for Tesla, it would work really good for us too.
Right.
And then Ford starts selling directly in North Carolina, and then they bypass they can sell cheaper than these other people can, because they don't have to hold inventory.
You bought your car online or no?
No.
Okay. Well, I haven't bought my car.
I shopped for it online. I did a lot of shopping around and emailing people and stuff. But ultimately, I went somewhere and bought it. Yeah.
It is possible, right, to go online and totally customize the car you want online, and then it goes to the store. I mean, no,
but I think ultimately you have to go through a dealership.
Oh, I see.
You can't have, at least that I know of. I don't think you can go on Ford's. We just keep using Ford as an example, but go on Ford's website, pick out a car and say I want to just go ahead and pay for all of this at this price. Send your check to them or whatever and have it show up to your door.
Okay.
Or even have it just show up to somewhere.
Right.
I think ultimately you can order it, but then I think what happens, at least this is my assumption from the little bit of stuff I did, you can build the car you want, but then ultimately they say, here's 5 dealers in your area. Which one would you like to get you a quote on what that car will cost? How much they'll charge you for it.
I see. Okay.
Right? So they kind of have here's the listed price. But that price is really high. You wouldn't ever really want to pay that price.
Oh,
so then, they call you and oh, we can give you a better deal than that, or maybe just charge you that. It just depends. But
gotcha. Okay.
Yeah, I don't think there's no but it makes sense, right? For me, I would rather just pick the car based on reviews and customize it, and then just have somebody drive it on a flatbed to my house,
right,
and drop it off one day.
So cars are a little different, I think, than most things in that, you have to sort of negotiate when you're buying a car. I don't negotiate when I'm buying a toaster, right? But yeah, so but okay, so a house is a huge investment, and also there's limited supply of houses. So there, it's a little bit different.
Okay.
But even like take a huge TV. Let's say you want to buy a gigantic $6,000 TV. There's some cars that cost $6,000, right? So
yes,
there's some Kias out there, I'm sure, that cost. Anyway, the point is there's things that cost a lot of money that don't involve negotiation, right?
That's true. Yeah.
And so I feel like the whole like car negotiating, go to the salesman and haggle thing, like that can disappear. Like I don't feel
so.
I feel like
I agree. I don't like that aspect. In fact, I almost went. There was one dealership we had which just said like, look, we don't like this is our price, and they weren't like joking. Like I got the sense like legitimately they had no intention to negotiate with me, but their price is also really really good.
Yeah.
But then, unfortunately, as much as I didn't want this to happen, but it ended up better, I guess, I went and found other people who didn't believe me until I said, like what this other place was offering. But then they actually did manage to give it to me cheaper. And so I was like, I'd rather give my business to the place that wasn't going to make me negotiate and was giving me what, from all intents and purposes, seemed like the best deal. But then I did manage to negotiate a better deal somewhere else. It's kind of like, But I do think, cars are one of the most expensive things you would buy.
Yeah,
I also think, which increasingly I didn't know this, but if you're willing to negotiate, you can't actually negotiate on TV purchases.
You can't do what?
You can negotiate on TV purchases, yeah.
Oh.
So, if you're going to buy something that expensive, you can... Well, even just, from a low level, you could shop around, right? Yeah. You go to Fry's or Best Buy or...
Oh, yeah, definitely.
Whatever. You could bring an ad, right? Like, hey, they got it cheaper, can you give me a better deal than this? You can do... And then the other thing is, cars are typically not... just like a standard item. There's a lot of options, right? Yeah. So if there's a TV, you could do that, right? If you start to include things like extended warranties and whether it comes with an installation kit and stuff, you can especially negotiate on those parts.
Yeah, actually, you just reminded me. Sorry to interject. Pro tip: if you're getting a new phone, you can almost always get a free case. So the past 2 or 3 phones I've paid for, I've got free cases just because. I just say, look, this price is pretty high. I could probably get it cheaper. Walk out the store, come back the next day, you get a free case. So whether that is worth it to you or not, but yeah, to your point, you can negotiate on a lot of things.
Yeah, so I think maybe it's our generation, maybe it's just who we are. I have no idea what it is, but I personally don't really care for negotiation. I'd rather just everybody be upfront, which never happens, but I don't really like doing that, but I do know that sometimes if you're willing to say something, it's happened to me before a couple times. I've, just mentioned something, even I saw you guys offer this thing or whatever on this other item. Could I get it on this? And they're like, yeah, sure. And they'll give me some other thing or a discount or this coupon expired. Could I go ahead and use it anyways? And in reality, they really shouldn't give it to you because sales are tied to coupons, so they try not to run sales and coupons at the same time,
right?
And this kind of thing. But if you just ask and then they say okay, either because they don't know what they're doing or they just really want to make the sale, there's a lot of wiggle room for all things. That was a far off topic. I really do want the day though where I can just go online, choose what I want, get a fair price. And have the car brought to my house.
Yeah, that's all it makes sense.
And then only have to deal with negotiating and selling my previous car.
Yeah, I think that we can get there. I mean, this is a step in the right direction.
Unless it gets banned everywhere.
Well,
wait, this is a step in the wrong direction. North Carolina banning it.
Yeah, the article is a step in the wrong direction. But yeah, I mean, eventually, cars will, there's already so much information on the internet, right? That you could go to a dealership. It'd be amazing if you could take a car and on the test drive, take it to CarMax and try and sell it.
Yeah, I mean, we're dragging this topic out.
Have you seen that story from the person who... he said he could beat any chess player in the world, even a grandmaster, as long as he picks 2 of them. He can guarantee to beat one of them, and he would just go back and forth playing the move the other one played.
No, I haven't heard this story.
Yeah, so let's say there's 2 grandmasters. You say,
yeah. You just play them off each other.
Yeah, as long as one plays white and the other plays black, then you just play the other move, and eventually you beat one of them, right?
Yeah.
So you could. Okay. It'd be nice if you could do this with cars.
Okay, I didn't. Okay, maybe that's a little bit extreme, but I mean, we'll see. I don't know if we'll ever get there. It's interesting. And it's also hard because, we're going off topic, but there's this whole free market aspect, right? But then people want to change what that is. Tesla's getting, unfair advantage or whatever. We want them to play on the same field. People don't want the game to change when they're playing a game and doing good at it.
Right, that's true.
So I think there's some things, it's kind of interesting when you see this and it's really? This is kind of blatant that you're just trying to protect your entrenchment and not allowing things to change.
Yeah, that's definitely what's going on here, no doubt.
Anyways, that was way off topic quite a bit, so time for...
Tool of the show. Oh, I did a double there.
Wow. Reverb.
Tool.
And I didn't even have to do that in post, so...
Whoa.
All right, you're up first.
All right, I'm up first. So my tool of the show is TypeScript. So
that's where you type out scripts. Why do I'm so compelled every time to make some stupid comment when you say this? It's really annoying. I'm sorry.
It's calligraphy. No. So JavaScript is totally ubiquitous, right? I mean, JavaScript's the only language that works on all major browsers. So if you're going to do something client-side in the browser, you're going to be writing JavaScript. Now JavaScript, so Apple, and Google, they don't quite get along, so neither one wants to support the other one. Like, Apple doesn't support Java, programming in Java. Google doesn't support Objective-C for Android. Windows, I don't even know what you write in. I guess C#, who knows. But one thing I do know is that all of them support the JavaScript compiler. So, if you were to try to submit the Java compiler, in C++, like that compiler as part of your app to the iPhone store, they will just reject it. And this has happened before. People have tried; they've been rejected over and over. But the JavaScript compiler, totally legit. So JavaScript has taken over mobile for the same reason that it's taken over desktop, which is, it supports all the major phones. So with JavaScript becoming so popular, people have been trying to sort of, try to get the best of both worlds. Try to use JavaScript and get this, universal, support, but then also try to get things like type safety, things like static analysis, these things which make life a lot easier if you're doing, say, C++ or Java or something like that. And people who have listened to a lot of our episodes know that we talk about this at length. So, long story short, TypeScript is a dialect of JavaScript, but it allows you to annotate JavaScript with types. You're allowed to say, hey, this thing should only ever be an integer, and this thing should only ever be a string, etc. So then what happens, you run a TypeScript compiler, which takes all of these annotations, and it also supports some cool things like classes and inheritance, things like that. It takes all of your TypeScript files and converts them into JavaScript, and it transpiles them. And when it does, it doesn't create some horrendous JavaScript that you would expect, like just some complete disaster. But it creates JavaScript that's actually very readable. And along the way, it makes sure that you haven't violated any of your type constraints. So it's pretty cool. I've been using it a little bit. I haven't made anything with it, but I've been using this Turbulence TypeScript game engine, and I'm really liking it. I'm a big fan.
Nice.
Yeah.
So is it much different than like other things I hear, which are like JavaScript derivative stuff?
Yeah, so there's CoffeeScript.
CoffeeScript, Dart.
There's Dart. So one cool thing about TypeScript is, as I mentioned, kind of an annotation system. So you can take existing JavaScript code and just rename the files to .ts.
Okay.
And then TypeScript will compile them back to JavaScript, which is a no-op in this case. But it will. But you can take an existing JavaScript project and it immediately is a TypeScript project. That was kind of the appeal for me. Actually the appeal for this Turbulence developers when I was reading their blog. They said, we had a ton of JavaScript code, we were getting all these runtime errors, and it's kind of a mess and unmaintainable. And we needed a way to sort of add type safety and other nice things, but we didn't want to rewrite our code from scratch. So yeah, Dart is pretty awesome. Definitely look into that. Have we talked about Dart?
I don't know.
I think we did a show on it. Yeah, we did a show on Dart.
Okay.
So, yeah.
We have terrible memory.
Well, it's our 27th show, They say humans can only remember 7 things. We'll talk about that in our AI maybe. But anyways.
Oh, we did. We did a whole show on Dart. Man, I feel stupid now.
Yes. So there's a bunch of languages.
Oh, I remember now, yes.
TypeScript is pretty nice because it is JavaScript. At least it can be. Cool. So what is your tool show?
That was episode 12 for anybody wanting to play along at home.
Oh yeah, definitely flashback time.
You can go listen to us talk about Dart then. No, I remember talking about Dart. I just was trying to understand the difference because I haven't heard of TypeScript before.
Gotcha.
To try to relate something new to something I know.
Nice.
Java is just C++ with garbage collection, so that's how I understand Java.
Sure, and batteries.
Sorry, that was not a funny joke. In my continued not doing good at sticking to actual things that are useful as tools, I have another game.
They're tools for your mind.
They're tools for me to spend time.
Yeah.
And I think actually worse, I think this one is iOS specific, and that is ridiculous fishing.
Ridiculous.
So ridiculous fishing is truly ridiculous. The game starts out as you're basically a guy on a fishing boat, but it's not like one of those old games, if you ever played one, like with the little handheld fishing rod and you like flick it and you like wind or whatever, like I don't remember what they were called.
Oh yeah, I remember, like Bass Pro.
Yeah, or something. Yeah. So it's not like that though. It's much more ridiculous.
Okay.
So you cast your lure into the water, but there's no casting mechanism. You just drop it,
okay.
and then it starts to fall through the water column,
okay.
and there are fish, but you're really trying to avoid the fish.
Oh,
because you want to get down, because good fish are like lower, so you want to get down. Like not, it's like different types of fish versus like each type only has one size. But anyways, you like navigate your way down, trying to avoid fish. And the first fish you run into, you're gonna hook him, and then you start coming up. But on the way up, any fish you hit, you also hook. So kind of like Katamari, whatever. You like getting bigger and bigger clump of fish on your hook.
Oh man!
But it doesn't grow. So like, but anyways, it does.
Yeah.
Okay, you're sending now through the water column, the opposite of however far down you went. And that would be pretty ridiculous because it's got like a crazy vector art style and pixel, but it doesn't stop there.
Oh, okay.
As soon as you get to the surface, instead of having collected those fish, you don't actually get the fish until you shoot them. So the fish explode into like a rain of fish, and then you have to take your finger on the touchscreen and tap the fish to shoot them. And some fish you have to shoot multiple times. Some fish are negative points, so you actually don't want to shoot them, or you lose points. So you shoot all the fish as they're raining up and then down. And then any ones you miss fall into the water and you lose them. It doesn't count.
So do you get one cast and then you started, like, is each cast a different game? A different instance of the game?
Yeah, basically. So like so once this thing is done, then it's over, right? Like you have gotten some money and then you can buy upgrades. So like things that allow you to not have to go back up the first time you hit a fish, kind of like a health or whatever, or like a better lure that allows you to chainsaw through fish and score points that way, or like better guns, so like maybe like a orbiting laser cannon that blows fish up, or maybe a shotgun or a machine gun, and like depending on your style.
Reach the bottom? Is there a bottom?
Yeah, so there's different fishing holes you go to, and they have different depths, and there are different things at the bottom, and there's a progression and a story. And I won't spoil it, but it's a ridiculous story that I don't think I really understand. But then there eventually you get to an endless mode, and then kind of you can try to collect all the fish. You try to, anyways, various things.
That sounds awesome.
But it's a pretty cool game. But there's a story here which I think is fairly interesting. So the developer of this, Vlambeer, I'm probably saying that wrong. Also, you might have heard of the game Super Crate Box.
Okay.
Maybe not. They made this game as well, but they had. What was the name of it? It was like Radical Fishing, which was like a web game, which was something I haven't played it, but something fairly similar.
Okay.
And after they released that game, that was like 2011, I think. Another company came out with something called Ninja Fishing, which was essentially what this Radical Fishing was, but just like for iOS devices.
Oh, someone copied.
So someone copied them, and they were already starting to make this ridiculous fishing or whatever. It was like a blank copy. Like people knew, but like it was still. What I gather, like at least somewhat successful.
Wow.
So what did they do? Like they just like went and spent more time like refining their game, and it took them till now, a couple years, let it die down, that thing to pass, and then come out with this even better game and kind of like show them, and supposedly it's doing like really well.
Wow.
Anyways,
so
I would encourage you to check it out. It's $3. That's right. $2.99.
It has 3,000 ratings.
That's pretty high.
So,
at least 3,000 people have bought it.
Yeah. I don't know.
So yeah, I don't think you can get the exact number of downloads they've had. They don't tell you.
But I think realistically, like, what is it like?
It's like at least 1% of people will rate.
Yeah, let's say like let's say 5% of people rate to be conservative. Then multiply by 20, it's 60,000 downloads. It's pretty good.
No, that's not that good. I think it's way better than that, actually.
Okay. All right.
So I think they've sold lots of it.
Oh wow. Okay.
Anyways, but it's regardless of how many they've sold or not sold or the story, it's a ridiculous game and you should try it out.
Yeah, it sounds absolutely ridiculous. Hopefully they'll make an Android version.
Anything
2D should be
straightforward. Yeah. I mean that's always an interesting thing, right? Like things which get made for one and not the other for various reasons, and various people have opinions. And
see if they wrote it in TypeScript.
You should mail them a letter, Jason.
I know.
You should get a petition going.
Combine our tools here.
You should get a petition going. All right. Now it's time for the book of the show.
Ooh, book of the show.
All right.
So my book of the show is a graphic novel, which I always find really funny. Like,
it's graphic, like it describes a lot of gore in the novel.
Yeah, I'm fine.
I did it again. I'm so sorry.
I'm fine being really immature and calling it comics. Like, it doesn't bother me. I don't feel like I'm less of a person. Anyways, so this is a very long comic, hundreds of pages, but totally awesome. And it's called Dungeon. It's actually written by a couple of a French author and illustrator, but then Joanne Spar and Louis Trondheim, but then it was translated to English. It's pretty awesome. Basically, the story is, you've played so many video games where you have to go in the dungeon, slay the dragon, save the princess, etc., right? Or you've seen so many books or stories about it, right? This sort of takes that concept and turns it on its head. So the comic is about you are the protagonist is a dungeon master, and actually in the first volume, which is what I linked to, which you can buy through our Amazon web referral, which is pretty awesome, is you play as the son of a dungeon, or you follow the son of a dungeon master, and then the future volumes he sort of inherits the family business. The business is, getting warriors to come into your dungeon, letting them slay some slimes and building up their confidence and letting them, go back to the town, get some more weapons, come back, and then at some point killing them and then taking all their armor and weapons and pawning them off. So that is the business of the dungeon.
That's evil.
Yeah, so if you ever played like Dungeon Keeper or any of these games, it's kind of a very paradoxical, and it's pretty awesome book. Highly recommend it. They have to go to their board meeting where the board of trustees looks in on the dungeon and sees the graphs, and they talk about how they don't have hockey stick performance in their dungeon and what can we do. At one point they have a branding problem because the dungeon is too close to another dungeon, so they kidnap a princess so that all these warriors start coming to their dungeon instead, and then the enemy dungeon kidnaps their princess back. So it's just pretty funny, pretty awesome, and highly recommend it. It's a great read.
That does sound interesting. On the notion of lighthearted and less serious thing, my book is Hitchhiker's Guide to the Galaxy.
Woo-hoo.
So this was written by Douglas Adams.
Yes.
I believe the order of this is that originally this was a radio show on the BBC.
Right.
And then he wrote this book. It's a very, if you've never heard of it before or read it before, a lot of pop culture geek references have their start in this book.
Yeah, if there's a lot of jokes that you don't understand, it's probably because you haven't read this book.
that's possible. But it's really, it's kind of like a comical take on science fiction with a lot of hilarity, but it's a really good read. There is a story there. It has a lot of interesting tangents and things that don't always make sense, but it's funny, and it is really classic geek material.
Yeah, I mean, they interviewed, there's been tons of interviews with Douglas Adams, but one in particular that I read, he actually hitchhiked throughout Europe, and he had a book called Hitchhiker's Guide to Europe. And it was about sort of how to hitchhike through Europe with no money. And he went through Europe completely penniless for months. And so that inspired him to write this Hitchhiker's Guide to the Galaxy. And so it's a phenomenal read. So yeah. Yeah,
definitely. If you haven't read it before, you should definitely check it out.
Yeah, totally.
And it's been out for a while now, 25 years at least.
Yeah, definitely.
So
yeah, I mean, it's a pretty reasonable price, I think. I haven't bought it in a long time, but I think I looked it up and it was...
It's okay. That's all right. It's well priced, and you probably even get a used copy if you want.
Yeah, $14.
Oh, okay. Yeah, not bad. And there's
That's 5 books.
It was
$14.
Yeah, I was gonna say. So it was supposed to be a trilogy, but it ended up being 5 books.
What is that called? Quintilogy?
I guess he has a funny name for it. I forget. I've seen a quote by him about it, but I can't recall what it is. But some classic characters from that book.
Yep.
So
any book where this isn't too much of a spoiler because it's super early in the book, but any book which the Earth gets destroyed, like the first chapter, has to be amazing, right? I mean that sets the stage for awesome.
But as long as you make sure to bring your towel, you'll be okay.
Yeah, definitely.
All right, on to theoretical artificial intelligence. Okay, maybe artificial intelligence theory.
Yeah, definitely. So we're actually doing a two-parter.
2 parts.
So the first part
And
is...
best of all, they're both free.
What? This isn't like one of those Zynga games where, we give you the first part and then we charge you,
Wait, that's a brilliant idea. Well, no, because then the first part would have to be really good.
Yeah.
And then, like, the second part wouldn't be as good. And then people would be, like, mad and want their money back.
We're setting up microtransactions. We're just going to go on tangents until you pay us $1.
Please insert coin here.
Yeah.
To continue, that would be 25 cents further, please.
Yeah. Oh man! So you have on here the Turk.
No, first we're going to talk about. We will not cover everything in AI because we don't have enough time.
Yeah, definitely.
So this I liken this to, we'll do a tour of artificial intelligence.
Yeah.
Jason and I will be your tour guides.
Definitely, we'll hold your hand.
What? Stop.
We'll hold your hand and walk you through the world of AI.
So we're going to go over some highlights. This is by no means comprehensive, and we may try to shorten some things, and hopefully that's not too bad. If there's anything we miss and you really want to hear about, feel free to email us. Next episode, we'll read some listener feedback. And so you guys have been doing that, and so keep doing that. And if you have something you want to hear, please go ahead and write us. Let us know. We can cover something in more detail. I don't know that we could cover something in less detail because we'll have already covered it, but
we'll do our best.
So my favorite, AI thing when I think about AI, this is kind of bad, I don't know, I think about the Turk. So if you don't know what the Turk is, this was in the 18th century. I guess it started around 1770 was kind of the exact time, and this was billed as a mechanical automata chess master.
Right.
So this was a robot you could go visit who sat in front of a chess table and would play chess very well.
Keep in mind, 1770.
People were amazed. It went on tour for nearly 100 years. And people would pay to come see it. It was just like a, what in the world, like this machine. People were amazed to see this machine that could beat you, could play. I remember this is really weird, but going to North Carolina as probably like a 3rd or 4th grader with my family, and going somewhere where they had various arcade machines, and they had a chicken that played tic-tac-toe.
What?
So this is really bad. People should not have done this, but it lived inside one of those crane machines, where the crane tried to.
No way.
But no crane.
Okay.
But in a glass box, and you would put a quarter in, and the chicken would go first. So I assume what happened, they drop a little feed into this box, and the chicken would go over and peck, and it was labeled
X or something.
Input box or something. And the chicken would peck, and then the screen would show what position it picked. And then you would go next, and then the chicken would go over and peck some more food, and then you would just back and forth, and the chicken was unbeatable. Nobody could beat the chicken.
That's so awesome.
And so I guess maybe this early childhood memory of not being able to beat a chicken, and being embarrassed that I couldn't beat a chicken at tic-tac-toe,
oh my goodness,
shaped my life.
That's amazing.
And so the Turk was similar. This was this machine, and I think there's a lot of drawings of it. Kind of the chest was open. You could see all these gears, kind of whirring and spinning and figuring out how to play chess. And for 100 years, people were amazed at this. And then it was finally destroyed in a fire. And they wrote about the secret of the Turk was that there were chess masters inside of him, cleverly hiding themselves and manipulating the arms of the robot to play chess. But I think, and we can go through history of all these things people thinking about and talking about AI, but just the kind of amazement that the average person has with some machine, something that's not human but smarter than them.
Yeah, definitely. That's pretty awesome. That's where Amazon Mechanical Turk came from.
Yeah. So nice, so clever name.
Pretty awesome. So so one of the hallmarks of early AI was Alan Turing's Turing test, and it basically, in a nutshell, says that if a human can't tell that whether they're interacting with a computer or another human, then said computer has passed the Turing test. And so it's been something that sort of AI people have constantly gone back to. Yeah,
it kind of goes to what I'm saying, right? That people are they want to know something smarter than themselves. So if you could make how do you tell when a computer is intelligent? Well, if you can't tell the difference between it and a human, it's at least as intelligent as a human.
Yeah, and we'll definitely cover that because there's a lot of interesting areas we can go there.
Also, we talked about last episode, I believe our book was Foundation series by Isaac Asimov.
Yep.
And I think that was my book. And Isaac Asimov also has a very popular kind of saying related to artificial intelligence and robotics in particular, where he had the 3 laws of robotics, which are: a robot may not injure a human being or through inaction allow a human being to come to harm. Mm-hmm. Number 2, a robot must obey orders given to it by human beings except where such orders conflict with the first law. And 3, a robot must protect its own existence as long as such protection does not conflict with the first or second laws. So, anyways, read all that to say that I think it's interesting that people were fascinated and are still fascinated by these laws, to think that you could get to the point where it would even matter that you had these laws. Like, that if something was capable of worrying about whether or not it obeyed by the laws, you had kind of arrived.
Right. And to think about, the laws of robotics dealing with safety and being so integrated with safety shows sort of the inherent fear of AI, right? Even today, people are worried that, some AI will go horribly wrong, or AI will take over the world. We won't need people.
Yeah, it's a classic Terminator thing, right?
Yeah, exactly. Yeah.
Yeah, so people are like fascinated and fearful of, going back to the Turk, like that this thing can be smarter than them and that they won't have a good way to stop it.
Right. So in the early 50s, there was a lot of pioneering work. There was the first neural network, which we'll cover in more detail, definitely in the second episode. But suffice it to say that there's an artificial neural network, which is sort of a mathematical approximation of sort of the electrical patterns that go on in a human brain, and the plasticity of that. So in other words, how your brain sort of transforms to capture information and store it there. And we'll cover that in more detail. There's also Arthur Samuel's famous checkers AI, where some concepts like minimax and planning and things like that were introduced.
And I think it's interesting, like the relationship of even to today games and artificial intelligence, because I think it's a way for like defining a set of rules, almost like the Turing test, right? Like you're defining a world that has a set of rules, the game, and then you can pit yourself against the opponent, the computer. That like you can put somebody on the other end, and as long as if you're both obeying by the same set of rules, you've essentially created a level playing field.
Yeah, definitely.
So playing a computer in checkers, like if it can beat you in checkers, in some ways, like it's bested you at checkers, right?
Right, like in the domain of checkers, it's easy to pass the Turing test, right? It's much harder to pass the Turing test when, locomotion, speech, all of these other things are involved, right? I mean, once you've done that, then you've made a...
Although, interestingly, you and I went to a talk by a person who does board game design, and I thought he had an interesting point where he was saying that writing a game for the computer, sometimes it's very easy to write an AI, but playing an AI is very different from playing a human.
Oh, that's true.
That you can passing the Turing test of checkers is like, you can win at checkers, but people don't get the feeling that they're playing a human.
Right.
You're playing distinctly different and maybe in a way that a human wouldn't normally play.
Yeah,
he mentioned over-aggressiveness.
Yep.
That often, human opponents will try to play well without being mean. But the computer is just going to do whatever is best in its odds.
Yep. Another thing, too, is take checkers, for example. So you learn to play checkers a human learns to play checkers from either somebody or a book that somebody has written. So there's sort of this, what's called the quote-unquote eternal conversation. There's an eternal conversation on checkers. So the first people who invented checkers said some things about it and how it captures some part of the world, world dynamics. That's probably what inspired them to make checkers, probably war or something like that. Then there's people who sort of took that, expounded on it. Some people wrote books on strategies, and so your understanding of checkers is actually derived from the people who taught it to you, and then subsequently everybody else in that stream, right? Whereas a computer is just going to learn checkers as a mathematical function, right? So it might be exploring checkers in a completely different vector than you are.
Yeah, so almost like if somebody makes an analogy to you about how to determine what to do, then you're likely to make different decisions than the computer, which doesn't understand how to equate playing checkers to moving in a cornfield.
Yeah, exactly.
I know that's making sense.
That's why game AI is so hard. People think, game AI, I'll do all this planning and stuff like that, and they think all these sophisticated methods and things that the Mars rover would use, right? But it doesn't really work. I mean, think about it in even just in Mario. If the Goombas bounced every now and then, that'd probably be harder to jump on them, right? But it doesn't make the game more fun, right? Part of what makes Mario fun is the predictability. You hit the turtle shell, it knocks 8 Goombas in a row, you get a 1-up, it makes your brain happy, right? Serotonin's released. Right? So making a computer that can sort of facilitate a fun experience is actually really hard. A lot harder than making, as you mentioned, the perfect player, right?
So leading into the 1950s and the quote-unquote golden age of artificial intelligence.
Yeah, so at this point, everyone thought, oh, we have it. We figured out neural networks, and we know how the brain, works and how electricity causes you to store information. So that's it. We got it figured out. We're going to have human-level intelligence. And they thought that for about 15 years, 20 years or so, and realized it's not true. And we'll get into why that is. But yeah, so after the golden age, which is around mid-70s, we have what's called the AI winter. And this is where, people started to lose faith in AI. And the goals that AI set were so lofty that even if AI had made tremendous progress, which it didn't, it still would have gone through this period of remission, right? But it went through a terrible winter where basically people thought AI was kind of dead. There's not really any point to it. Then in the 90s, you had this sort of renaissance of AI. A lot of people attribute the renaissance of AI to, better, faster computers, Moore's law, things like that. And also just more sophisticated methods and just a lot of infrastructure, both on the research and on the computation side.
In 1996 was when Deep Blue, a supercomputer and program combo, beat Garry Kasparov. In chess. And I always find this story interesting because, first of all, I didn't even realize it was that recent. Well, relatively recent, I guess.
Oh, totally.
And it's kind of like if you look at their checkers, world-class checkers in 51, and it took 45 years to play something that's played on the same board. You play chess and checkers on the same, or you can play on the same board.
Yeah, I think it's even the same size. Right?
Yeah, same size, same board, right? And just different pieces, different rules or whatever. And look how drastically different. And I mean, obviously, chess, you can even tell simply it's much more complex than checkers.
Right.
But it took all this time to kind of get there. That's interesting to me. It's also interesting, this huge controversy over were people helping it? Was it a ploy by IBM to increase their stock price? Nobody's ever fully convinced that today, I think people are fairly settled that it's, at least my understanding, it's pretty hard. Chess, you can sometimes beat a chess computer like the world-class ones, but...
Yeah, now it's at the point where the best chess computers beat the best players, and it's sort of a given that's going to remain forever.
Yeah, so now, but back then, in the intermediate years, there was a time when it wasn't quite clear, and even then, right, you would think, that was the first time that a computer had beat a reigning world chess master. Yep. And so, okay, that's it, right? But maybe there's all these caveats and special cases. And
one of the things I remember that was up for contention was they actually put all of Kasparov's games that he's ever played into Deep Blue's repository. So Deep Blue knew kind of Kasparov's strategies specifically. And so the argument was, if we took someone who wasn't Kasparov, would you have to train for each person, or is the system general, right? And at the time, I think that some of those were valid. I think that if you had another famous chess player play Deep Blue, you would have to train on that person for a while as well. But now they've gotten to the point where they'll beat anybody. Yeah.
Mm-hmm. So what is artificial intelligence?
All right. Well, here we're getting sort of the meat of the podcast. So, all right, let me get my soapbox out for me to stand on.
Okay. So I'll take a seat.
So first let's talk about intelligence, right? Because this by itself is pretty loaded, right? So when you talk about intelligence, you're talking almost certainly about human or animal intelligence, right? And so
or lack of it.
Yeah, if you're watching Real World, then you're so there's two main sources of intelligence. One is neural plasticity. So this is, if I tell you, hey, my phone number is 545-5555, whatever, then...
That's not really your number.
No, I'm getting phone calls already. Then a week later, I ask you what my phone number is and you recite it to me, right? There's intelligence in just memorization. And at a higher level, if you learn the layout of your house, and then the next week you unlock the front door and go straight to the living room because you know where it is, right? So there's that kind of intelligence that's learned after you're born, there's also a tremendous amount of innate intelligence. And so this is actually intelligence that is encoded in your DNA. So your brain is actually, constructed with a certain set of structures. Structures for language, structures for vision, and a lot of these structures have incredible complexity and what I would call intelligence in them. And so, things like vision, language understanding, these things are innate. They're not learned. It's not like, you might be blind. I think babies are blind when they're born, but that's not a mental thing. That's just a physiological aspect. But you actually have a tremendous amount of innate knowledge. Just to put it in perspective, giraffes and other quadrupeds, when they're born, they can actually run immediately on birth. In fact, giraffes specifically, they fall, I think, 3 or 4 feet out of the womb and immediately get up and run. So that's intelligence. And so
I don't think babies are actually born blind, though. It's something slightly different. But it's okay. Continue.
Oh, is it? Okay.
Yeah.
Well, yeah, that was a jump. But the point is, I know for a fact that babies are not born without the ability to see on a cognitive level, right? So, so that's intelligence, and intelligence is sort of passed on through the generations. It's encoded in our DNA, and our DNA is constantly undergoing mutations and things like that to add more intelligence and to make it more amenable, right? So this is a very slow process. It's not like your child's going to be born knowing geometry or something like that. It doesn't really work that way. But the fact is that people born now, or animals, let's say, born now, are much more intelligent than protozoans born millions of years ago, right? So now let's talk about artificial intelligence. So we want to emulate human intelligence. Like, we want computers, as we mentioned in the Turing test, to have conversations with us, to see, to recognize objects, to do all these things. But we don't have an Earth simulator, right? And even if we did have a complete Earth simulator that could really, really quickly simulate the entire process on Earth and evolution and all these different speciation, all these things, genetic drift, etc., it wouldn't probably come out the same, right? Unless we had an exact copy of Earth as a seed, we would come up with some other intelligent hypothetical species, right? So we can't go back and recreate human intelligence. Like, it's just not possible. So artificial intelligence is our way of saying, knowing we can't do that, how can we still make something that passes this Turing test? How can we make computers that sort of live in our world, don't really know our history, but are still able to relate to the way that we behave and interact? So that's kind of my Jason Gauchi's soapbox opinion of our intelligence and AI. So
I always find it interesting, the discussion about artificial intelligence, like these kinds of things. About there seems to be different camps. Like, some people who deeply believe in needing to understand how the brain works. Mm-hmm. Other people saying it doesn't matter. We can do something else and still be fine. Or like you alluded to, like, maybe it's important to figure out what you think happened and how we got here. Other people, not so much. We don't need to do that. But people can still make progress and create useful things regardless of which one of these camps they kind of fall into, or which path they're considering.
Yeah, definitely. Yeah, I mean, I think you definitely need to do both. So there are some concessions you have to make. I mean, the reality is human intelligence is almost certainly not perfect, right? I mean, there's almost certainly...
Speak for yourself.
Almost certainly, unless we all had Patrick's brain, there's almost certainly
that would be terrifying.
A better brain out there, right? Like some other thing. So, and there are things that computers are much better at than we are, like arithmetic, right? We'll never match a computer's ability to do that. So, you have to... But on the other hand, we want computers to pass that Turing test, which is fundamentally a human evaluation, right? I mean, it's a human domain that you want computers to succeed in. So you have to sort of do this balance between, studying the brain and sort of like, I guess, hacking the brain, quote unquote. As we mentioned in image processing, where you encode the blue, I believe it was blue, right? Yeah, you encode the blue channel more lossy than you encode the red channel, because humans are, less adept to blue. So that's sort of an example of someone coming at it from the biological side, right? But there's plenty of things on the mathematical side too, which can make a big difference.
Yeah, and then I in my opinion too, I think there's been somewhat of a shift from like artificial intelligence is all about passing the Turing test, to like, you know, and people point out things like search engines as this, right? Like they can do a lot of very useful things,
right?
Which, whether or not that's intelligence, it's unknown, but it's definitely a very useful thing that isn't an outcome of passing the Turing test.
Right.
Getting an AI sufficient to pass a Turing test doesn't solve the search engine problem.
Exactly.
So we get things which, you know, and maybe that's machine learning, maybe it's artificial, I mean, whatever you want to call it, but you know, kind of the advancements of computer, the future was always making a computer which was equivalent of a human. Yet we kind of ended up developing this other side branch where it was like, oh, making computers do even things that are more useful than what a human would be able to do.
Yeah, definitely. Yeah, it's a really good point. So, yeah, along these lines, this was a hot topic a long time ago before either of us were born, but it's still really important, and that's common sense knowledge. So when you hear this term, sort of common sense, you think of things like, if I was to ask a child, what's taller, a skyscraper or your house? Or, you know, things like that. They have a ton of common sense reasoning, right? And that's because human beings absorb an incredible amount of data. I mean, in the image processing last episode, we talked about how much data is in video, right? Uncompressed video. And it was enormous. It was like a dictionary every 10th of a second or something like that. You could fit the entire dictionary. So that's just from your eye, right? You have actually a lot of sensation in your ears, your nose, touch, especially your fingertips. And they're all of those data sources are extremely rich, and there's a ton of data, way more data than any computer can come close to processing even today. So the fact that, you know, humans are able to digest and process so much information is another aspect of AI that, you know, we're starting to make progress on. Especially now we have, there's that open crawl, which has, you know, the entire internet, 50 terabytes of the internet in it or something, right? So with things like search engines, databases, you know, and things like that, we're able to sort of create a small sample of the knowledge that we experience every day. And so we're starting to make progress there.
Yeah, I don't know, it's fascinating having a child and watch them, like, what they pick up and learn and the process of how they grow. But even, like, my daughter will see us do something in the kitchen or whatever, like, you know, do something with the pots and pans, and she has like a little play set of pots and pans, but they don't look like our pots and pans other than roughly resembling a similar shape. She has no ability, like, we've never really sat there and told her, like, this is a pot, this is also a pot, you know, like, we never went through labeling and said, like, these things are so, but she'll watch us do something, and we'll see her, observe her at her play kitchen washing her hands under a fake faucet that looks nothing like our faucet and doesn't emit water, right? And so she recognizes that this thing that I have here is the same as that thing over there, and she's able to kind of, she doesn't know necessarily why she's doing it, but she wants to do the things that we do, and she's able to figure that out all on her own. And it's like, wow, to make a computer do that would be like really hard. Like, I don't even know. Like,
it's amazing.
Yeah,
absolutely amazing. And I mean, she's only able to do that because think of how much information she's digested. I mean, it's way more than that open crawl database, you know, 100 times over, right? Maybe 1,000 times over. So, yeah, it's amazing, and that's one problem that, you know, has to be cracked still. So we'll just sort of wrap up. What is AI? There's some general goals for AI which I feel are pretty universal. So one is deducing. So in other words, have you heard of the canonical, like, monkey banana problem?
No.
So the idea is there's a banana hanging from the ceiling, and there's a chair against the wall, and if you just leave a monkey in a room long enough, the monkey will start to swing at the banana, but he can't reach because it's too far out of his reach. And then he'll start to understand, like, to take the chair, move it in the middle of the room, climb on the chair, and then get the banana. So the idea is the monkey has to sort of envision the future where he's standing on the chair, do some planning, etc. So that's deducing. There's also reasoning. So just reasoning involves a lot of sort of looking at the past and using that to determine the future, right? So I know I touched a stove, it hurt me, I got burned.
Okay.
I'm not going to touch stoves, right? And there's also problem solving, which gets into expert systems and things like that. And we'll definitely talk about all those in more detail in the next episode.
So what are some of the challenges? Like, we talked about maybe some of what we thought AI would be and how we didn't get there. So, I mean, there's obviously some things that got in the way.
Yeah, definitely. So, yeah, one thing that got in the way was this concept of strong AI. So people wanted, people had sort of reverse engineered the brain at a very low level. They hadn't done anything with DNA, which is, as we talked about, a huge folly, right? But they said, oh, if I have two neurons, one, signals the other one like this. And so our brain has, I think it's like 1 trillion neurons. So if I just do this 1 trillion times, I'll have a human brain. And that doesn't work. Now, I'm sure everyone listening to the show knows why. But, their idea of recreating a human really kind of set AI back. Another problem is whenever you're doing planning or reasoning, you have what's called a combinatorial explosion. So let's just take checkers, for example. So on average in checkers, there's I think like 2.5 moves you can make that are reasonable on average. So if you're looking at a certain board, there's, let's say, 2 moves you can make. So now you're looking at 2 boards, but in each of those boards, there's another 2 moves you can make. Right. So now it just explodes, right? Mm-hmm. There's also the knowledge representation. So this is incredibly difficult, right? How is knowledge actually stored? One common thing that you hear of is humans can only remember 7 things at a time. That's why most phone numbers are 7 digits, right? But we do this thing called chunking, where you might remember 7 things, but each of those 7 things is incredibly complex. And so you've sort of like collapsed a bunch of information into one quote-unquote thing that you have to remember, right? And that's what video games are all about. Like in Mario, it's kind of all about the context. Like if you're jumping over a pit, you know that you have like no room for error. But if you're jumping to hit a block to get a mushroom or something, you're much more relaxed. Like you might try and do that and hit a Goomba at the same time or something like that. So in video games, you kind of chunk different actions based on their context. So finally, the biggest challenge in AI is what's called the frame problem. And the frame problem is basically you don't know what affects a certain action. So for example, let's say you're getting out of your car and you want to know if now is a good time to get out of your car. So clearly if the car is moving 50 miles an hour, that's probably not a good time to step out of your car, right? But
unless you're being held hostage.
Yeah, then you could do like a barrel roll or something.
But probably not at 50.
No, yeah, maybe not. Maybe slow it at 30 and then barrel roll.
Okay.
But the point is like, the current temperature in France, for everyone who's not in France right now, does not matter. Whether, if the car is going 50 miles an hour or if it's not, matters a lot more than the temperature in France as to whether you should get out of your car or not. But how do you know what should matter and what shouldn't when you're making decisions? That's the crux of the frame problem. So if you don't know what matters and what doesn't, then you have to consider every possible thing that could exist. And also, the next time you make that decision, you don't really know what made that decision a good or bad idea the first time, right? Because how do you know that the weather in France isn't the reason why last time you got out of your car and you were hit by a bike, right? So knowing sort of what the context is for a particular decision is the frame problem. And that's actually extremely difficult. So
I guess that's a good thing about AIs for games because it already frames the problem for you.
Yeah, that's why games and AI are so intertwined.
Okay. So we're kind of like giving a little tour, like background, speaking at a very high level. Hopefully this is interesting to you. We're going to get to some specifics and some more hardcore stuff in the next episode. But kind of wrap up here, we wanted to talk a little bit about some of the cool things that AI is used for. We talked a lot about games, but there are some other things that are kind of classic examples of what AI gives us or attempts to give us.
Yeah, you want to go first?
Okay, so first one is Maxima, the computer algebra expert system. So it's something that's able to solve algebra.
Yeah, totally.
Is that okay? That was your point. So
actually, I thought you were going to go straight to Eliza.
Oh well, I'll talk about Eliza, and then you can talk about Maxima.
All right.
So mine, of course, sticking with useless things, is Eliza chatbot. So this was kind of like the early You may have seen it before. I remember seeing it at like a science center when I was a little kid.
Yeah, they actually have it. I was at the MoMA. The San Francisco MoMA has an ELIZA.
Oh, okay. Yeah, so there's like a computer. It says like, I forget what they're greeting, like, hello, what's your name or something. And you type, my name's Patrick. Hi, Patrick. How are you doing today? I'm doing good. I'm glad to hear you're doing good, or something. And then it kind of, so it looks for like certain keywords and tries to create a sentence or alter what you said in a certain way to make it get back. Often gets stuck and just kind of says like, I don't know what that is or something, Yep. But, it kind of gives you this illusion almost for just a second that, whoa, wait, what's happening? Am I really talking to somebody else?
Yeah, it takes some of what you say and sort of puts it in its next statement. Like you might say, I don't like diapers. And it will say, oh, tell me more about diapers. And so you feel like, oh, wow, it's really answering me.
Yeah.
Did I tell you I actually, and my wife was really embarrassed, but I know of a way to trick these chatbots because, so if people don't know, I got a PhD in AI and machine learning, so done this stuff for a long time, and so here's a pro tip: if you ever see an ELIZA bot at a museum or something, you can say something to the effect of, like what I said, I really don't like flies, and ELIZA said, oh, tell me more about flies, and I said, well, I also don't like bananas. And she said something, I don't remember what she said the second time, but then, this is the catch, you say, no fruit flies like a banana. And so you think about it, there's two ways to take that. Like, no fruit flies like a banana, or no fruit flies like a banana. And it flipped out, and it said, so I've done this before, and it just said, like, I don't understand, or does not compute, or something, right? But this time, it literally said, I joke you not, did you just wet yourself? It's what it said. Literally, and everybody around was like just busting off. It said something like, I don't understand, did you wet yourself? And my wife was so embarrassed. It was pretty epic.
I kind of want to go try this now.
Yeah, you should definitely go to the MoMA and give us a shot.
Okay, all right.
So, so we'll cover Maxima. So,
yeah, since I butchered it. By just reading what you wrote on the page.
So Maxima is a algebra expert system. We'll cover expert systems more later, but you could think of it as sort of like searching. But instead of searching through moves and checkers, it's searching through things that you can do in algebra, like dividing or canceling this number out, or removing an x from both sides, etc. And so it does really complex integrals and differential equations and things like that. Like if any of our listeners are in high school or university and they're taking I think it's Calc 2 or something like that, but where you study integrals and you have to memorize all these crazy rules, like the trig rule, like the derivative of sine is cosine, and derivative of sine squared is 1 minus cosine squared. I remember all these crazy rules. So this system, Maxima, knows about all these crazy rules, and then it will try different rules and get in and hone in on the solution. So you can say, give me the integral of this huge equation, and it will sort of crunch the numbers and figure it out for you. Yeah.
Another useful project which used AI was the DARPA Grand Challenge. So this was, the create a self-driving car that'll drive across the desert and then through a mock city. And this was kind of, first year was like a horrible disaster. And then they did it again, and it was much, much better. And, even just like the, 5 years or whatever, I guess, between however many years it was between the first one and the final one that they did, there's just like a huge progression in how good they could do, and, just the complexity of not only just steering the vehicle the way you want it to go, but recognizing where you want to go and, what to avoid and, all these things. And it's just, it takes a lot of planning, intelligence, getting to, like you talked about, the strong guy being able to kind of solve all the problems, and trying to put them together in something. Not that self-driving car solves all of the problems, but it has to solve many different kind of aspects of AI in order to be able to get from point A to point B. Because it's not just like move from point A to point B. It's like, well, how do I move? What's the best way to get there? How do I avoid?
What if things go wrong?
Damaging myself or damaging others, or all these things.
Yeah, they did the Grand Challenge, which was out in the desert, and then recently they did the Urban Grand Challenge.
Grand Challenge, yeah.
Which I found out later wasn't really urban, like it was a fake urban setting, so no one was actually at risk.
Well, there were people driving the other cars.
Yeah, but they were
yeah.
But yeah, still pretty cool. So, we'll do one more.
Okay.
So this is pretty cool. It's RoboCup Soccer, and basically the goal is I don't remember when this started. It was sometime while I was in university, but basically when it started, the goal was to have
1997.
There you go. To have a fully autonomous humanoid robot soccer team compete in the World Cup in 50 years. So by 2047, to have like full-sized human robots competing against like Germany for the World Cup finals. So pretty ambitious goal. They have an incredible amount of backing from like ACM and other organizations. A lot of interesting AI. Another student of mine, or another student that was with me in the lab at university, was working on this problem, and it's just pretty amazing the amount of progress they've done. They actually have, they sort of split it up into several domains. They have the full-sized humanoid problem, and at that point they're kind of like doing penalty kicks, and they haven't really made too much progress there, but if you think about it, that's very expensive, so that's kind of like the last step. But now they have sort of a smaller scale competitions with real robots that run around and kick soccer balls and stuff. It's pretty awesome. The Wikipedia link should point to some pretty epic videos of soccer matches
in the show notes. Yep.
Yeah. If not, we'll add some videos. But it's totally awesome, and highly recommend checking it out.
So that's interesting, though. Like we just talked about AI in game, but here's actually like getting a harder problem as opposed to just and I think they even do have a simulation league or whatever.
Yep.
But now you're trying to play. It's simultaneous as opposed to taking turns. So if you take longer to figure out what you're going to do, like that's bad. Other people run around you. Yeah. And then also like having to again getting back to like what the grand challenge thing, like dealing with it in the real world. Not only get to figure out what you want to do, but how you're going to do it.
Yep.
Like how do you actually do this? Yeah, this interesting thing. Do you think they'll make it?
So
2047,
2013,
in 30 years.
I think that they'll have humanoids playing soccer. I don't know if they'll compete in the World Cup. One thing I wasn't sure about is like if a robot slide tackles you, does it just shatter you? Right? I mean, how does that work?
But obviously, I don't think the rules probably permit them to play. They probably don't meet the anti-doping rules. No, something right. Like they probably don't meet the rules. So you can't. Yeah. You'd have to create a scenario in order to allow them to play. Right.
Yeah.
Like you're not allowed to make contact. I don't know. That's not really fair.
That's the thing is like I don't really know how they would deal with that part of it. So I feel like that's where the actual limitation is going to be. Like the AI will be sufficiently capable, but just the mechanics of stripping the ball from another player and not destroying them is going to be the hard part.
Yeah, you have to have the robots implement Asimov's 3 laws.
Yeah.
Then the players can't do anything because the humans will just tackle the robots. Okay. Well, I think that wraps it up for this episode. So next episode, we're going to be talking about in depth kind of how do you actually get these AI problems done? Like, what are the tools and techniques you're going to use?
Yeah, by the end of the next episode, you'll be able to actually solve AI problems on your own.
Or at least know what to go look up to work
on. Definitely. Using other people's source code.
Yes, you'll know the Google search that will give you the answer.
Exactly. Yeah.
All right, well, I think that's it for us for now.
Cool. Have a good one, guys.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.